sequences. This will go with 10.2a notes. So we're going to look at arithmetic sequences, finding the common differences, writing the rule, and then finding the nth term of an arithmetic sequence. So this is going to look really similar to something you've seen before. An arithmetic sequence is a sequence in which the difference between the consecutive terms is constant. And if you remember when we talk about linear equations, linear functions have a constant rate of change. We call that slope. So it's going to be really similar to a linear function with a constant rate of change or slope. In an arithmetic sequence, though, we call the constant difference d, whereas in a linear function, we call that common difference m, slope. Same thing, essentially. A sub 0 is going to be our 0 term. It's the term before our first term. So remember, we had a sub 1 as our first term. So a sub 0 is our term before that first term. It's also very similar to the y-intercept. It's when you plug in x equals 0, or in this case, when n equals 0. So it's our y-intercept in our linear function, and d is our slope in our linear function. So hopefully this will look familiar. It's just a common difference. So 3, 7, 11, we're adding 4 every time. So 11, 15, 19. Our common difference here was plus 4. 8, 3, negative 2. Here we're subtracting 5 every time. So negative 2 minus 7, negative 12. You're subtracting 5 every time. You have a common difference. These are examples of an arithmetic sequence, something that changes at a constant rate. So deciding whether it's arithmetic is deciding, does it have a common difference? Is there something common being added or subtracted? So in this first example, the difference here is plus 4. Does that work for here? Yes. Negative 2 to 0, though, is plus 2. And then this is plus 2. So this would be no. It has some pattern to it, plus 4, plus 4, plus 2, plus 2, plus 4, plus 4, but it's not the same common difference throughout. Here would be plus 6, plus 6, plus 6. This is a yes. The common difference is 6. I can identify the next term being 35. So a rule for the nth term of an arithmetic sequence. The nth term of an arithmetic sequence with the first term a sub 1 and a common difference d is given by this equation. A sub n equals d times n plus a sub 0. So the common difference times n plus the term before the first term. So if you want to write a rule for the sequence, you need to find the common difference and you need to find the term before the first term. So I always start by finding the common difference first. What's being added or subtracted? In this one, I am adding 15 each time, from 32 to 47. If it's not that obvious, you can take the second term and subtract the first term. And then you can see where I got the 15. So I got d equals 15. And I know that a sub 1, the first term, is 32. If I'm adding 15 going to the right, if I want to go back to a sub 0, I'm going to have to subtract 15 from that first term. So I have to do the opposite. So if I take 32 minus 15, I'm going to get my a sub 0 is going to be 17. So the term before the first term is 17. So now I have d and I have a sub 0. So my general term is a sub n equals dn plus a sub 0. So my rule will be a sub n equals 15n plus 17. So this should look really familiar to y equals 15x plus 17. So y-intercept is 17 and a slope of 15. If I want you to find a sub 12, the 12th term, remember that I want you to plug in when n equals 12 and figure out what a sub 12 is. So this is like plugging in x equals 12 and getting out y equals something. So if I plug in 12 for n, I'm going to get 197. So the 12th term is 197 of that series, or sequence, I mean. So let's try one more. This one we're going down 30, 25, 20. So that means my common difference must be subtracting or a negative number. So I'm subtracting 5 each time. So my common difference is negative 5. And I know my first term is 30. Since I'm subtracting every time, I'm going to have to add 5 to get back to my term before the first term. So my a sub 0 term, 35. So then I can plug it into my formula. So you're going to have dn, so negative 5n, plus a sub 0, so plus 35. So there's my general rule for this arithmetic sequence. Now if I want to find the 10th term, then I plug in 10 for n. So negative 5 times 10 plus 35. It should be negative 50 plus 35, which is going to be negative 15. So the 10th term in this sequence is negative 15. Finding the nth term given a term and the common difference. So in this example, one term of the arithmetic sequence, a sub 8 is 50. So the 8th term is 50, and the common difference is a fourth, 0.2500, 0.25. Write a rule for the nth term. So I'm going to start with what I know. I know my general formula is dn plus a sub 0. And I know that my common difference, d, is 0.25. I also know that the 8th term is 50. So remember that this is like when you plug in n, you get out a sub n. Or when you plug in x, you get out y. But in a sequence, they're n a sub n points instead of x, y. So when I plug in 8, I get out 50. So I can use these points, 8, 50, plug in n and a sub n to help me find my a sub 0 term. So I'm going to plug in 50 for a sub n. I'm going to plug in 0.25 for n. So I'm going to have d left. And I'm going to plug, oh wait, that was d. Sorry, my bad. I'm plugging in 0.25 for d, and I'm plugging in 8 for n, and I'm trying to solve for a sub 0. So 50 equals a fourth of 8 is 2 plus a sub 0. So I will need to subtract 2 from both sides, and I get 48 equals a sub 0. So now I can go back and write my final answer. It's going to be a sub n equals 0.25 n plus 48. So finding the nth term given a term and the common difference. That's the same thing we just did. So I'm going to go on just for time. Finding the nth term given two terms. So two terms of an arithmetic sequence are the 5th term is 10 and the 30th term is 110. Write a rule for the nth term. Then write a value for n for which a sub n equals negative 2. So this one's going to be a substitution problem, similar to ones we've done before, except for this is going to be a linear system, essentially. So I have 2 points. Remember that the points are n, a sub n. So my first one, 5, the 5th term is 10. That really means that when I plug in 5, I get out 10. That's my n, a sub n. And then I have another term. When I plug in 30, I get out 110. That's my n, that's my a sub n. That's from this point right here. So if I use my general formula, a sub n equals dn plus a sub 0, I can come up with 2 equations with 2 unknowns. So 10 for a sub n equals, I'm going to plug in 5 for n. So I'm going to have 5d left there plus a sub 0. Over here, I'm going to have 110 equals 30 goes in for n, so 30d plus a sub 0. now we're going to have to do some substitution. So I'm going to solve this side over here for a sub 0. So subtract 5d from both sides. And I'm going to end up with 10 minus 5d equals a sub 0. Now I can plug that a sub 0, this 10 minus 5d, in for this a sub 0 over here. So a substitution, similar to what we've done before. So I'm going to pull that over here a little bit. 110 equals 30d plus, now I'm substituting in this a sub 0 for this. So plus 10 minus 5d. Now I'm going to solve it. I'm going to start by combining like terms. I have d's on both sides, or 2 d's on one side of the equal. So combining like terms there, I'm going to get 25d plus 10. Subtract 10 from both sides. I get 100 equals 25d. Divide by 25. And I get d equals 4. I'm going to hold on to that. I need to bring it back up over here and plug it in to solve for a sub 0. So if d is 4, then plug that back in. And I'm going to get 10 minus 20, which means that a sub 0 equals negative 10. So now I can go back up to my equation and write my final answer. So I got d is 4, so 4n, and a sub 0 was negative 10, so negative minus 10. And that's my final answer there. Now, this question here, then write a value for n for which a sub n equals negative 2. Essentially, it's asking you to plug in negative 2. If you know that a sub n equals 4n minus 10, it wants me to plug in negative 2 for a sub n and solve for n. So then I can solve for n by starting by adding 10 on both sides. I'm going to get 8 equals 4n, divide both sides by 4, and n would equal 2. So essentially, this is telling me that the second term is negative 2. When I plug in negative 2, I get out negative 2. When I plug in 2, it's the second term. All right, that's it for this lesson.